Hey there. This installment on my series of videos on enzymes is going to talk about some real-world applications of enzymes and how they're used on an industrial scale and within the medical field and how that impacts us as well. So the examples I'm going to share are very, very few compared to the enormity that exists with the use of enzymes in our society. So I'm going to talk about some examples of enzyme use within the food industry, with detergents, clothing manufacturers, and manufacturing and textiles, and in particular medicine, which many of you who are going into a medical field are probably going to feel that that's the one that is most applicable to you, and continued studies in pharmacology classes or things like that may come back to talking about the role of enzymes in diagnostic tests and also medicine therapeutic uses of enzymes. So I am going to activate my pen. I don't know if I'll use it or not. I might. So a couple of examples of enzymes used in food industries. Within dairy production, rennet is an enzyme that is used in the cheese making process. Lactase is an enzyme that's going to break down the sugar called lactose and metabolize it. Protease is a classification of enzymes used in proteins, and catalase particularly is used for breaking down hydrogen peroxide. I'm not sure if that's the intent with this or if catalases is a category in and of itself. I'm not really sure. So you can see that there are various, I'm not going to go through each of these lists because you can look at the screen. Within the brewing industry, baking, wine and fruit juice making, and meat, papan is a known meat tenderizer, and it is an active ingredient in many meat tenderizers that you can purchase at the store. So another example of I have a little yawn, of where enzymes are used industrially and apply to us in our food industry is the production of high fructose corn syrup. Now, fructose is fruit sugar, and it is found naturally within fruits. Sucrose is table sugar, and sucrose actually consists of two monosaccharides put together. This hexagonal piece represents glucose, and then fructose happens to be a 5-sided cyclical structure. So sucrose is 50% glucose and 50% fructose. And when we eat sucrose or table sugar, our body does break the sucrose down, so we have 50% fructose and 50% glucose in our bloodstream. There have been studies, a lot of studies, linking the high consumption of fructose products in connection with health problems like heart disease, diabetes, and stuff like that. So there's a concern about the ingestion of too much fructose. When they make high fructose corn syrup, it's really kind of strange because they literally start with corn kernels and have it undergo a series of chemical reactions, and they end up with the high fructose corn syrup, which happens to be about 55% fructose. So a little bit higher in fructose content compared to regular sucrose table sugar, which is 50%. But that's how they consider it high fructose corn syrup. This is an aerial view of a high fructose corn syrup plant. In the next slide, you can get a sense of all of the steps involved. I'm sorry about the audio. starting with corn and going through a whole series of steps. Many of these involve the processing of enzymes and ending with the final syrup. So a very complex operation to make that high fructose corn syrup really quite artificially in actuality, starting with cornstarch. Another food enzyme that's often used, I think this is really cool, is if you've ever gotten the little orange mandarin oranges in the can, all of the peel has gone completely away. Pectinase is an enzyme used to peel the oranges and leave the fruit in perfect condition. So enzymes are also used extensively in the detergent industry, in our clothes detergents, in our dishwater detergents, even within cleansers like shampoos and body washes. So there are 4 major enzyme classes that are used in the detergent industry, and proteases are designed specifically to break down stains or food residue that have protein in them. Lipases break down fats. Amylases break down starch, which the name for that is amylose or amylopectin. So amylases break down stains from starch-based foods. And then, cellulases, it's kind of interesting because I just learned this today when I was doing a little bit of research on it, that in our laundry detergents, the cellulases break down small cotton fibers. So cotton, it comes from a plant, and the carbohydrate in plant plant cells is cellulose. And cellulose is the fiber, it's wood fiber, but it's also the fiber in cotton. So putting cellulases into our laundry detergent actually keeps the surfaces smooth, because small cotton fibers that might pile up on the fabric get broke down, and it keeps our clothes looking better, longer, and not all piled up. Not piled up like a pile, but those little beads of cotton that sometimes you'll get on there. Within the textile and the clothing industry, cotton, again, has cellulose in it. So cellulase will be an enzyme that they can contribute to stone washing, some textures that they put into denims and stuff like that. And there you can see that there are other roles for how these enzymes are used in textile applications, but I don't really know what these things mean. I was just showing you as an example that there are enzymes used in the textile industry. Now, one that is going to be more applicable to many of you is the discussion of how enzymes can be used within medical diagnosis. And whenever our body is in a disease process, our cells die and become damaged, and the enzymes get released into various body fluids as a response to that disease in the body. So here are some enzymes that can be measured in body fluid tests that can be indicative of disease or specific health problems. So we're looking at the alkaline phosphatase can be used to diagnose liver and bone disease. We have pancreatic disease being diagnosed using enzymes, heart and liver problems. The next slide, I'm going to talk specifically about this lactase dehydrogenase and how it can be used to indicate whether a heart attack has occurred. So if you look at this, there are two types of lactate dehydrogenase in the body, and one is LDH1 and one is LDH2. Now, when our bodies are operating under normal conditions, the ratio of LDH1 to LDH2 is so that there is less LDH1 and more LDH2. If you have a heart attack, the enzyme levels change in the body such that the LDH1 levels are going to be higher than the LDH2 levels. So just looking at the ratio of these two enzymes with respect to each other can indicate whether or not a heart attack has indeed happened. So I just have some final thoughts about enzymes. Enzymes are one of the most extensive industrial processes made. So we have to make enzymes. They have to be collected and isolated so they can be sold to customers who are using them in their textile operations or in the food industry, or putting those enzymes into their detergents, or for whatever reason. So those have to be created and collected and isolated so they can be sold, and that process is generally very, very complex, which leads to a couple of things. Industrial enzymes are really quite expensive parts of an industrial operation, and often sometimes in very short supply. So while they are used extensively, the use of enzymes is an expensive component, and sometimes can be hard to come by. So those are just some final thoughts on enzymes. I hope that you learned some applications of enzymes. Again, the list that I've included is so small compared to how enzymes are used. You could probably create an entire course on how enzymes are used in society. So thanks for watching.